Yeah, I think there we are. So, hi, welcome everybody. I'm glad that a large number of people responded to the suggestion I had made to present this. My name is Emilian Klein. I am a Frenchman living currently in the Netherlands, about 1 hour south of Amsterdam. I am working currently as an interface analyst. I will prefer not to mention the name of the company, but to give you an idea, it is the largest company in the US that has the most number of large hospitals. So it's focused on, pretty much large hospitals and university hospitals. And I'm working for their European branch, where in particular we are in charge of hospitals in the Netherlands. So that is to give you a quick idea of what my role is and why I am familiar with HL7. So I will start now sharing the presentation that I've prepared, so you will not see me for a while, but I think that's okay, right? One thing that I want to make sure is some people, if you have questions, don't hesitate in asking. I think it would be nice if you could mute yourself in the meantime so that we can go through the presentation. But if you have something to ask or to mention, go ahead, unmute yourself and ask me. I will try to keep an eye on the chat, so in case you have a problem with your microphone, you can write something there, but I'm not sure that I'll have my eyes kept on there all the time. So let's go. So I have made a few slides, which I will publish later, but I want to start with a quick introduction of GNU Health, in case people are not familiar with it. So it is a free and open source health hospital information system. I guess you could also call it an EMR, electronic medical record. I think that the aspect of free is very important. It's not necessarily the free as in beer, but the free as in freedom, as specified by the GNU project. In case you're not familiar with those concepts, I would suggest you click on the second link on the presentation when that is made available. But otherwise, I guess most of the people that are in this call have an idea what it is. I copied here a little extract of the goal. I'll let it read it to yourself, but it's from basically GNU Health website. I want to state as well that I am not necessarily officially affiliated with GNU Health. I have an interest in packaging GNU Health for Debian, which is currently in the experimental branch of Debian. So I have not done any real development with GNU Health, but if folks are interested, I would be happy to help implementing HL7. What is HL7? So the name itself means Health Level 7. It refers to the 7th layer of the OSI model for the technical oriented people amongst us, which means application. So the idea behind that 7, it's the creators wanted to explain that it was on a high level. It's not just a communication protocol like you would have, for example, TCP/IP, but it's really higher. It's supposed to be able to transfer meaningful application in a structured way, if you want to see that in a short manner. It refers the term HL7 to both a non-profit organization that creates healthcare standards, but also the actual standards themselves. So you will speak or about the HL7 organization or about the HL7 standards. Speaking about standards, they are open standards. So the term open is sometimes used in different ways. I think in the beginning, HL7 presented itself as open in the sense of, yes, you can do it between two systems and we're open, but not really in the sense that we are used to. Since April 2013, they are actually open in the sense of freedom. They are free to download. You need to register with the HL7, but prior to that, you actually had to be a member, which involved paying quite large fees to the HL7 organization. There are a few how will you say that, versions of HL7. I will explain a bit what those are. So there's a version 2.x, which, as we'll see a few examples later, is a character delimited text. That is the primary standard that is used in hospitals. So see this as your patient database and your lab, and they will communicate between each other using the version 2. That is also the oldest, about 25, 30 years, I think. I should probably have noted that, but it's a rather stable, if you want to see it that way. There's a version 3 that is XML format. So it has a few benefits, also a few drawbacks, but the idea is all kind of newer applications are usually developed in the version 3 format. And by newer, I mean, for example, here in the Netherlands, we have a nationwide infrastructure that the government has pushed, and so that hospitals between them can send information. The idea would be, for example, you go to your, so you have an accident on the street, you are brought with an ambulance to the hospital, the people in the emergency room can basically click a button. It will query, for example, medication to this central index, which does not contain medical information itself, but knows where it's available. It will ask, for example, your home doctor and your pharmacy, do you have medication? They will send it back so that the emergency room can have that. That kind of newer, and I would call that a bit more complex interactions are typically done in V3. The problem with V3 is it's rather complex. It's a lot of UML, very abstract models, which it doesn't necessarily make it easy for vendors or for software projects to implement that. Then comes FHIR. FHIR, which means Fast Healthcare Interoperability Resources. I say here, do not call it HL7 v4, but that is more or less what it is. It's also an XML-based syntax, but which is meant to overcome a lot of the issues with version 3. And the fast, the first letter, is very important because it is meant to be read in one weekend and be able to implement a new interface, which in V3 would be, let's just say it would be impossible. It's much more complex. FHIR will be, let's say the first real release will be in January. I actually attended yesterday the HL7 Netherlands National Congress Day, where one of the 3 or 2 kind of promoters or inventors of FHIR explained that. So it is a new and upcoming. I think that in the future it might well be more and more important. But for what we are discussing, the version 2 is still the most important to start with. That is what will enable you to exchange patient information, lab orders, lab results, that kind of stuff. The last point I wanted to mention is that there are a lot of local flavors. So let's say there's the international/US HL7 standard, which is kind of what everything is based on. And then you have, for a lot of different countries, a local chapter, if you want to see that. So to take the example that I'm most familiar with, we have HL7 NL, so Netherlands. They specify things that are specific to the Netherlands. And to give you an example, we have something called a BSN, which is basically a social security number. The HL7 Netherlands standards specify that it must be sent in a specific way, and it has specific rules that you need. You're not allowed to just send it. It has to be verified with a central national identity that, yes, this SSN belongs to this people, this person with this address, etc. Or another example is the last name. Usually you would think, well, there is just one last name. In my case, that would be Klein. But no, in the Netherlands, we have 4 bits of last name. So 2 big categories, your own last name and your partner's. Think typically about married women, but hey, Netherlands is pretty liberal, so you've got married men, married women, and all kind of combinations. So you can say, this is my own name, this is my partner's name, and we have also something called voorvoegsels, which is basically like a prefix. And those are stored usually separately because about half of the population starts with VAN. You're probably familiar with the painter Van Gogh, or Van Gogh, as we call him here. If you were to just sort it alphabetically, your phone book would have the half of the country under the letter V, and you don't want that. So the prefix is actually put at the end. So you would sort Van Gogh, the painter, you would search for him under G. So that is an example, 4 pieces of a last name, and that is specified in the HL7 NL, not in the US. And I guess there are, I haven't checked, but I guess there's one for Argentina. I know there's one for Colombia, Hong Kong I saw, France, Germany. I guess there's one for Canada as well. Have fun looking that up. So my recommendation, and I think you could ask a lot of people around to start in a hospital, it's really the version 2 that you want to look at. It's just the most used, so there is a high probability that the software you want to interact with supports HL7 v2. A few examples of what kind of interfaces you could have is a patient registration system. So the demographics information, name, address, phone number, etc. But also what we call ADT, admission, discharge, and transfer. So basically, this patient is now in this bed and room in this department, and then gets transferred to somewhere else, and then the patient is discharged, goes to home, a message will be sent out. So that, an example, for example, a pharmacy system could then say, well, if the patient is gone, I don't need to keep the medication because he's not in the hospital anymore, so they can cancel all the orders. Another type is laboratory. So I always like the examples of a kalium and a natrium. So a physician places an order, says, I would like to order blood tests to check the kalium and the natrium, and for example, a complete blood count. The lab ordering system, the ordering system would send an HL7 v2 message to the laboratory. The lab would perform the work and return the results. So this is the value of the natrium, this is the value of the kalium, and that would be then stored also in the patient demographic system that would display that in the chart. And the last one that I took as an example, billing. Well, we know that money is also important to have hospitals continue to be able to provide their services. So you can exchange what's called a DFT message, which tells you, so an example of the lab, hey, I have performed these blood tests, so this is what people should pay us as the hospital. And then you have your central billing system who is able to sum everything up. And when the patient goes home, they say, well, this is the bill. It could go to the insurance if the patient has insurance, or maybe it's a patient that does not have insurance, and there are some rules in your organization of how you handle that. Does the patient have to pay it himself, only a part, maybe everything? That really depends on the country you're in. As I mentioned, it's stable. It's in use in hospitals for more than 20 years. The fact that it's text-based makes it rather compact. If you've read XML that is 200 lines long, it can be a bit tired. The negative side, as we will see in the next slides, is that it can be challenging to read/count, because you need to be good in math, you will see. If you have to count until the 20th field, it can be a bit tiring. How is an HL7 message structured in the version 2? And from now on, I will only discuss the version 2, so no version 3 or FHIR. Version 2 is composed of segments. A segment is a line. We will see in the example after that. Each line or segment is separated in fields. So it's basically the pipe symbol, this bar that you see, separates different fields. And by fields, think, for example, this is the name, another field would have, this is the phone number, another field would have other information. So those are separated by pipes. Then components. The components, for example, of a name field, you would have, this is the last name and this is the first name. This is an example. For subcomponents, I just discussed the example of the last name in the Netherlands. We have 4, and actually there's a 5th one, which is how you would display it. Those would be separated by the ampersand symbol. And a field can have repetitions. That is the tilde symbol. The concept of a repetition would be, for example, if you are admitted and you have several admitting physicians, the same field that says admitting physician would have two doctors in there. First doctor, the tilde, and the second doctor. The values that I said, the pipe, the up caret, the ampersand, and the tilde, theoretically they can be changed, but in practice everybody uses those symbols. It's just easier. Everybody that knows HL7v2 is used to seeing that, so I've never seen a production system using something different. So we were talking about an HL7 message. This is one. I have taken this one from the HL7 version 2.7, which is the latest version in the version 2 brands. So from the documentation from HL7. And before I explain to you what these are, I just want to have a little moment so that you can look at it. So I have tried, because the lines are pretty long, to make sure that when a line wraps, it starts with a few spaces. So here in this example, we have 5 segments or lines: the MSH, the EVN, the PID, the NK1, and the PV1. Those 3 letters that I've just used, that is basically how the segments are called. MSH means message header, so it's, think about it, metadata. What type of message it is, when was it sent, from which system to which system, what version, 2.7 you see there at the end. It's a production message, which you see just before the 2.7. So it's metadata. EVN is the event itself. So you could have a message that is sent for something that happened in the past. For example, a patient is admitted, but the person in the system registered it 5 minutes later, so the message would be from, for example, 10 hours and 5 minutes, but the actual admission, so the event itself, is from 10. So that is the difference between the event and the message header. Then the big one that we see here is the PID, patient ID. Here you will see a patient number, the name, address, phone number, all that information. We'll come back to that in detail after that. NK1 means next of kin. It's maybe a term you're not familiar with. It basically means emergency contacts. Who is your, like, if you have a problem, who are the people that we need to call, for example. I'm simplifying it a bit, but that gives you the idea what it is. In this case, it's the spouse that is sent. And the last segment that we see here, PV1, patient visit. There can be multiple, it can PV2, etc. But this one segment indicates information that is specific to the visit we're talking about. So a visit, just think about it, an admission. So in this case, it will tell you that it's an patient that is admitted at the hospital, and then it's a with which doctor and surgery. I see that David has asked a question, meaning that the HL7 message is all uppercase. Is there no recognition of lowercase? That is a very good question, one that I have actually gotten every time I implement a new hospital. Yes, you can send mixed case, and often that is what the people in the hospitals would prefer, because if you want to display it in another system, you maybe don't want to show it everything uppercase. And sometimes the mixed case can be difficult. It's not always only the first letter that is uppercase. Maybe sometime a letter in the middle can be uppercase, especially, for example, in the US. So it is usually nice to send it uppercase. But I think it's maybe for historical reasons. Most of the examples that I see are all uppercase. The aspect of uppercase makes it easy, I would say, that for a bit more older systems to compare strings. You think about systems 25 years ago. Well, you just put everything to uppercase if this string equal to this one, and it's easy. Nowadays, mixed case is not so much a problem to compare, but I assume, I'm not saying that it's the complete truth, but I guess that's the reason why a lot of it is uppercase. Nicolas asked a question about the encoding. This one is indeed pure ASCII. I'm just checking if I don't see any character that would contradict that. The thing is, I took this example from the, how is that called? The US or the international HL7 standard. And I have to say that usually in the examples I see in the US, and my colleagues also in the US, they don't care too much about non-ASCII characters because it's not something that is really that present. Most people will be there, will have, for example, if a Chinese person goes to a hospital in the US, they will have a phonetic transcription in Latin alphabet, and that doesn't contain any of the weird characters that we Europeans or other countries are using. That being said, there is support for encodings. So it's not in this example, but in one of the MSH segments after the P and 2.7, you can see there are extra fields defined in which you can define the encoding used. So basically the answer is yes, you can define encodings other than ASCII. I know that here in the Netherlands we do use non-ASCII characters, and we usually use some kind of Win 1207, I think, encoding. It's a very old encoding, but which for some reason is used in most hospitals. And Greg just made a comment that in Ontario, Cancer Care Ontario likes to use lowercase, and he points to an example. Yes, as I said, it is possible to send lowercase or mixed case. Okay, so we've had a look at this message. Now I will explain to you a bit what this is about. So this message is what is called an A01, A01. It's an admit or visit notification. Think about it. A patient has just been admitted in our hospital. This is what you would send out so that everybody knows, oh yeah, patient is admitted. How do you know this? Because it is in the MSH, what is it, 2, 3, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So in MSH 9, you have the ADT01. I will get to counting a little bit later. Just know that MSH counts a little bit different than the rest. So if you were thinking that it was MSAH, don't be worried. I've thought about this a long time as well, but there is a little twist which I will explain. But let's go through this message and understand who this patient is and what this is about. So we know this is an admission message. There's a little bit of text, which again I have taken from the HL7 specs, and I have put little colors so that we will go through each piece of information. But just so you read already, it's about a patient that was admitted on a specific date by a doctor in a specific department, surgery. And we know which room it is, which bed, and which unit. So let's go through it. It's a patient, so we look at the PID segment, patient identification. Adam A. Everyman 3, that is sent in PID 5. And I know it's PID 5 because I'm working a lot. You will, if you get in touch with HL7, you will get to know a few typical IDs. So PID 3 and PID 5, the patient ID and the name, that is part of the fields that you will get to learn. I don't know all the fields are on top of my head, but those I do. So we know the patient's name. He was admitted, again, why? Because it's an A01. When was that? That is what you see in the EVM, event segment. So we see at what moment he was admitted. By whom? By this doctor, which is sent in PV1, the patient visit. What you see here, both a name and an ID. So we as humans like to use names. It's easier to say, hey, I have an appointment with Dr. Aaron A attending, instead of saying I have an appointment with number 004777. But as you know, computers prefer numbers or IDs. So what we see here in what is red is a combination. So we have a number, then an up caret, a last name, an up caret, the first name, an up caret, and then a middle initial in this case. Usually systems would use the name, the ID. So if you were to send this, for example, to a lab system, they have probably a list of all their doctors, and they know that the ID of this doctor is 004777. So they will actually not really care about the text that is after that. that is usually how it works. Some other systems, they will be a bit less sophisticated, and they will not have a list of patients, or sorry, doctors, so they will just take it and put it as a string in their database. Surgery, yes, that is sent in the PV1. I think it's 10 on top of my head. I don't want to count now because, as I said, you get tired of counting. Where is he? He is in room 2012 in the bed number 1 in the nursing unit 2000. So basically the department has an ID of 2000. Then again, here you don't see the names. It is purely based on the IDs. So you would have a facility structure that is known in both systems. So if I tell you this is room 2012, your system knows where it is. And if you have, for example, a lab system, they can send somebody there to draw blood. That is what you would do. So I hope that the colors help you a bit to understand, to map from the sentence that we as human would say to the code. But it's not finished. Let's go a little bit further. So now we know about the patient and why he's here. We're going to read a bit more. So this message was sent from system called ADT1 at the hospital called GNU Health Hospital. To which system? To a lab system called GHH Lab. In which hospital? The same, GNU Health Hospital. So it's basically two systems in the same hospital. The patient information system called ADT1 sends this message to the lab. Now, I personally find this example a bit weird because this means you have basically just one system in your hospital. Typically, what you would have for ADT systems is, so you are the source of truth, you know your patients, you know who is admitted, and you will kind of broadcast that to all the systems in the hospital. And by broadcast, I mean usually there is an interface engine. You're maybe familiar with the Mirth software, that is an open source interface engine. So you would send this one message to the interface engine, and then the interface engine knows that all the ADT information, it has to broadcast it to the lab, to the billing system, to the kitchen system, to whatever. You could have a lot of systems. In the hospitals that I work with, typically an ADT message that we send out is sent to around 20 or 25 different systems. So every system that receives that kind of maintains their list of which patients are in the hospital right now and where are they. One thing that is typical to the Netherlands is about half of the system that care about this information are not receiving those ADT message. They receive a different kind of message, which we call a query. So instead of our system sending it to them, they can say, now I want to know where this patient is, and they will ask us, can you tell me what the information or where this patient is, and we will respond. The response will be exactly the same message you see here. Admission, yes, 18 August. Sorry, yes. Actually, specs because it was a mistake. 3 seconds. Can you hear me? I've just deactivated my microphone. Let's see. the settings. Is there any change now? Yes. Does that mean it's better? Can you hear me fine now? Yes. Okay. So let's continue. As I was saying, what you see here is the message was sent at the same date and almost time, but 3 seconds after the actual event took place. So here you see the difference between a message header information and an event. Okay, so this was basically the basic information. As you can see, there are fields that do not have colors right now. You are probably able to identify what those are. So after the name, we have a date of birth, then an M to indicate it's a male. C, I am not sure what it is right now on top of my head, but after that we have the address. We also have the phone number, and all in the beginning of the PIT segment, this PET ID 1234, that is your patient ID. And as you see a repetition after the term hospital, you see a number 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the social security number. And how do I know that? Because after the up carets, it says US SSA and then SS. I don't remember what SSA means. It's basically an assigning authority, and SS means social security. So you can send information, and then with an encoding after that, you can tell it, is this a local patient number, or is this, let's say, a national ID such as a social security number? So looking at GNU Health, now that we have a bit of introduction about what it's HL7, why would we implement HL7 into GNU Health? So I've just put a little phrase in there, integration with other systems. I think that is an important part. If you are at the core of the hospital, you will probably, your physicians or nurses, they're probably fed up of having to register the same information twice. So if a new patient comes, you have to enter it in your patient system and in your lab system. Not only is that extra work, but it's also error prone. You could mistype the name, or even worse, mistype the number, and then you are doing lab work on a different patient. All those things can be problematic. So if you have an HL7 capable system, you are able to communicate this information with other systems. I'm trying to lay out in the second bullet an idea of how we would do that, because obviously it involves a little bit of work. I would imagine that you could do that in 2 steps. The first step would be kind of the implementation of a base module. So the base module would be kind of generic HL7 handling code that would do stuff like handling events. So making sure that when you admit a patient in HL7, there is kind of something that is noted that says you should be sending a message out now for this patient, for this information, date and time, etc. Then there's the aspect actually of creating messages. So I'm separating those because maybe you want to still be able to admit patients, but you have a technical problem, your network is not working fine, and you cannot send messages out at this moment, so you will kind of keep all the messages to send them later. That could be an idea. And the third part would be we need to make sure that once a message is created, you are actually able to send it over the line. So think about a TCP/IP connection to some other party. And it can be either in the beginning when you test one specific system, but probably when you are in the hospital, you will want to send that to an interface engine, such as MIRTH, again, the one that I mentioned before. But there are lots of different systems. And the second step, once we have this base system, so kind of a way inside HL7 when a patient is admitted or when an order is placed to say, hey, dear interface module, can you please create a message for me and send it out? We can actually create specific interfaces. And which ones that would have to be determined. probably, I mean, my suggestion would be do a patient outgoing ADT, so admission, discharge, transfer, which also includes the registration interface. The reason why is if you don't have patients in your external system, you will probably not be able to do much more. You cannot place orders in your lab if you don't know who the patient is, that kind of information. So I would assume that if GNU Health is in a hospital the source of truth for patient information, it would be helpful in a first step to be able to send it out. Another one, and actually the second and the third, they kind of go together, that is on the lab side. So you would be able to send an order, please do this blood test for this patient, send it to the laboratory system if you are not, because I believe GNU Health is not a lab system, but maybe it is. Yeah, it would be great if somebody could bit confirm that. But anyway, maybe even if, assuming that GNU Health would be a lab system, maybe your hospital is currently using another lab system and they want to be able to send the messages there. So you could have an outgoing lab orders, and its little brother or a friend, if you want, is then the incoming lab results. And Sebastian is confirming that GNU Health is not a laboratory information management system, so that is a valid example. We would be sending orders out, assuming that the doctors in GNU Health can say, hey, I want to place these orders. And then when the lab has actually determined what the values are, it can send it back in an encoded manner so that in GNU Health you would be able to, for example, show graphs. This was your glucose in the last 10 days, for example. Little bit of ideas when. I think that it's something that will require some time, so I'm not really familiar with what the date of the next GNU Health release is. I think it's from what I've seen, it's rather regular, so I would assume that the next release, that is going to come too soon for this to be able to be there, but maybe the release after the next release or the release after that, that would be an idea. A few ideas on this module. What should it be able to do? So a few general things. You should be able to configure your interfaces. So let's say something we were discussing, the uppercase and lowercase. Maybe you want to have a setting that says these fields are uppercase, these fields are lowercase. Then an overview of your running interfaces, that would be handy. Maybe your patient interface is running and the lab orders is not running because the lab has downtime or they're installing an upgrade. So you want to be able to independently stop or start some interfaces. Then generally we make two families. We talk about outgoing interfaces and incoming. So on the outgoing interfaces, this module should be able to handle the event. So when a patient is admitted, let's assume that, just think about logging, basically. Yeah? It's logged somewhere, the patient is admitted, and then the module says, oh, look, there is a new admission that happened. Let me create a message for that. The actual manner how we would do that, probably not using the actual logging, but it's to give you an idea. And so the outgoing interfaces should be able to do that. And obviously, maybe it sounds a bit redundant, but to make it clear, when an event happens, you need to be able to create a message and then send it to the external board. And on the incoming side, it's kind of the opposite. You need to be able to receive messages. So think about listening on a specific port. You would probably have one port per different interface. Hey, a new message came in, this is a lab result. Then you need to be able to parse it and file the information to the database. So that means stuff like making sure that, yes, the patient ID, it's a patient we know. You are telling me this is a result for the order number 123 I sent out. Yes, this is the order I can find. It is exactly the same, so I have asked an order for a complete blood count, and you're not sending me a result for something different. So all that parsing and verifying then leads to filing the information to the database. And let me just, so a bit on the technical side, what exists out there. So I know GNU Health is coded in Python, so there is an actual Python HL7 library. It is BSD licensed, so that means for the ones that are a bit less up to date with licenses, it should not be a specific problem to include that with GNU Health, which is GPL licensed. The code itself is hosted on GitHub, so you can have a look at it. It is available in the Python package index, which I know GNU Health is also using as one of the possible spreading mechanisms of GNU Health. And also it is packaged for Debian. I know this because, as I mentioned in the beginning, I have interest in Debian packaging, so I know it's packaged. But the level of the library is not necessarily what I would consider complete. Namely, the official latest release has or is lacking support for components, repetition, and the numbering is off. So it's basically like Python, it's 0 based, whereas in the HL7 world, people start counting with 1. So it means that if you, in this Python HL7 library, you are talking about pit 5, you are actually talking about pit 6 in the HL7 standard. So that is a problem. But I put there a link to in the process of being merged, because together with another individual, we have made patches to that library to support that. I have to say I'm not very pleased with the way it looks like, and I mean my code. It's not the nicest Python code you could have. It has a lot of empty lists because, yeah, you need to start with number 1. So probably there are ways to improve it, but at least it's a first step towards fixing. Now you can use components, repetitions, you have numberings that are coherent with HL7. So you could think that maybe to start the work, you can work off a branch, a fork of the official Python HL7 library. And it's been about 1 year since we made that code. We are in constant discussions with you will see if you go to that link who is involved in there. So, and actually, you will have seen on the GNU Health mailing list a mention of that merging, because the discussion on the bug tracking there was then redirected to the GNU Health mailing list. To finish, a few links. So obviously a link to GNU Health's website, a link to the HL7 specification website, a link where you can create your account and get access to the standards, and the documentation of the Python HL7 library, which I mentioned. And that is the end of the presentation. So what I propose is I will stop sharing my screen. Hey, I'm back. I would propose that we have a little round of questions and answers. So I think it would be nice if we not talk everybody at the same time, but go ahead if somebody has a question, unmute yourself and let's have a little discussion. I won't believe you if you're telling you don't have any questions. I'm sure there are a few things that came up. We had a few questions during the chat. Maybe while you think about the eventual questions that you might have, let me go back to the presentation and I will show you something that I discussed but not much in detail. So about the numbering, I have to go back and the presentation closed. And there we go. So share my screen. Yes. Let's go back to numbering. So I'll go with the example without the colors. As I mentioned, HL7 numbers started with 0. Sorry, I made a mistake. Start with 1. So if we take the example, for example, of the pit segment, this number 1 here is actually located in pit 1. Pit 2 is empty. And then we've got the values pet ID 1, 2, 3, 4, 5, upcurrent 5, upcurrent M11, basically until the next upcurrent that comes there after this pipe. So this entire content is PID3. And actually, I will not show you the presentation, but the actual content so that I can select that. Yes, and now I share this here. Okay, you should be able to see here now when I select. So as I was mentioning, PID3 is all of this. And the reason is we started with 1, 2, and now 3. And we've got PID4, PID5, etc. until we get to the caret return. This is not actually it's an invisible character, right? Unprintable. I don't remember if it's character 10 or 13, but it's one of those two. The idea is until the end of the line, you are in the same segment. And everything in between, you've got to count. So that's what I mentioned in the beginning. If you want to go to PID 15, well, you've got to start from the beginning. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is a long one, 11, 12, 13, 14, 15, and I'm not even sure actually if this is 15 because I would think that this is 13, 14, and this should be 15. So I probably miscounted. That is just also an example how complex it can be. So obviously there are tools. For example, if you were to show the how is it called in your user interface, you could have, for example, a little plus, and when you click on it, it will split it out. Yes, Nicola, you are actually correct. It is zero indexed with the name of the segment being the leaf 0. That is actually very correct. The only thing is the segment name itself does not contain any relevant clinical information. So you would never really care about PID0 or NK10. Really, what you care about is everything that starts here.
No, yes, indeed, but it was to solve your problem with the empty stuff in the Python HL7 you were talking about.
Yeah, that is actually an idea of how you could fix it. You could set in the 0 array the number 0 to the first one. You could set the ID. The problem is if you want to call it. It is a bit more complex.
Yes, it's redundant indeed. And
yes.
What about escaping if, I don't know, for whatever reason you have to use?
That is a very good question. So assuming that I have a name and my name contains this symbol, right? Upcurrent. That is a problem because now this is bit 5 and this is bit 6. But no, really my name is this entire thing. So the escaping in HL7 works with the escape character, which is encoded here, and I can discuss this a bit later, but I think maybe we don't need to go too much into detail in this introduction. The idea is you would have 2 escape characters instead of this, plus a value. And I'm probably going to say something incorrect. I would say it's F for field, but I'm not completely sure. There are 4, so for the 5 different characters here, each one has an escape sequence. I know there is a \E, \L. Sorry, I don't remember exactly. I always look it up. But this is the way you would escape it. It's 2 backslashes and a specific character. And then when you receive a message, you would unescape this, and you say, oh, if this sequence of character is in the message, well, then it means that this is this, and that's how you would display it. So yeah, very good question. As I had mentioned in the beginning about the numbering, just to finalize this one, MSH is numbered differently. You would think that, well, this is MSH1. No, this is incorrect because this is already MSH2. MSH1 is actually the 4th character. So that is pretty confusing because you would want to count like this is 1, this is 2, this is 3, but no, because of the way the message is encoded, it starts, every message starts with MSH, the 3 letters, uppercase. That's how you could recognize it. Then the 4th character, it identifies for your rest of your message what will be your character to separate fields. And that's back to the beginning when I said theoretically you could use different characters, but it's not very useful or used. And then you have those 4 characters which are meant here to represent the separation of components, of repetitions, what will be your escape character, and what will be the subcomponent. Yeah, Nicola, did you have a question?
Yes. What would be the protocol used by Hospital to exchange messages? Is it FTP, HTTP? I don't know.
Yeah, so there is. It basically goes via TCP/IP. So it is an active connection that is made between 2 systems. I think it is called MLLP, which is the most used in hospitals. I have to admit that I am not. Let's say in my work, I am basically working at this level. I have never had to create the actual physical layer to send messages, because that is included. But I believe MLLP is the protocol that is most used. Don't ask me what it is.
MLLP.
I think so. I will look that up as we speak. Health 11. I see here a mention of hybrid. So MLLP, it says a large portion, and I'm looking from Wikipedia, large portion of HL7 messaging is transported by minimal lower layer protocol, MLLP, also known as lower layer protocol, LLP. For transmitting via TCP/IP, header and trailer characters are added to the message to identify the beginning and ending of the message, because blah, blah, blah. So there's a whole thing. There is a specific protocol, MLLP. I know it's possible to send it via TCP/IP, and I assume that if we were to implement this in GNU Health, we would probably go with a TCP/IP route. That is what's most convenient. Again, remember HL7 has a lot of history because it's pretty old, and probably you would have wanted to create a new protocol in that time. We know now that inventing new protocols just for the sake of it is not necessarily very efficient. So we can reuse. But let's see, maybe there is an MLLP library in Python that we can use. Who knows?
Maybe.
Yeah.
But in fact, the problem in numbering is just a problem about reading the documentation. You never use the number into other messages to say, okay, I relate to this part of the...
Exactly. It is something that you would use in documentation, or also between humans to say, hey, this is what... hey, look at PIT 5, this is the patient ID, etc. I am actually looking up the PDFs. So let me show you an example of the HL7 specification. I will share my screen or change the screen that I'm sharing. Where is it? Is this one? So that is what I mentioned in the beginning. The standards are now freely downloadable from the HL7 website. This is the chapter 3 of the version 2.7. And actually, as a matter of fact, I met this person yesterday, Irma, at the HL7 Netherlands Congress. You see a few names of hospitals that I've been working with. The idea is each segment and each type of message is defined. So here, you remember in the beginning we had about the A01 admission. If you click here, it will tell you what is an admission message, when should you send it, etc., what kind of information. And then here below, you have all the segments. So without going too much in details, you have segments that are mandatory, so like this one or this one. There are some that are optional in brackets, and with the curly brackets, things that can repeat itself. So you see, at least you need an MSH, an EVN, and a PIT segment, and all the others are, oh, PV1. Yes, you need to know where the patient is admitted. And then there is specification for each of the events. So you have one for a discharge, a transfer, a new patient, all kind of things, cancel of the discharge, patients that are merged. There is a lot of events. Like you see, we're already in A55. Usually, systems do not support all messages. You would start with a number and then you increase as your hospitals need more and more. And then as an example, let me just jump to the PIT segment. Sorry, that does not transmit very well on video. Yeah, so here is the definition of the PIT segment. Obviously, it tells you a lot of information. You can see also that you can see the demographics of animals, so you could use that, for example, in a pharmacy, in a veterinary system. It's not purely limited to humans. Then here is a definition. This is not very handy, sorry. Definition of the segments, and that's what we were talking about, the numbering. So here you would see PIT3 is defined here. It's the patient identifier list. There is a lot of information. It will tell you which type of data. Let's not go into details, but if you're interested, Chapter 2 will tell you what a CX, what's an XPN, etc., what's a DTM, date time, etc. It will specify everything. And then for each one, for example, if we were to look at PIT7, the date of birth, that is a very simple. It says patient's date of birth and time of birth. For example, if you have babies in your hospital, you know the time. Usually, you only know the date. And for complex segments such as PIT5, which you were mentioning, the format XPN, it's stated here, but as you see, it can be pretty complex. And then it goes further because subcomponent of family name, so just this one segment can be composed of all of this. And that is what I explained in the beginning, specific to the Netherlands. Your own surname, your prefix, your surname, the prefix of your partner, and the surname of your partner. And then in the beginning, you just show how you would, for example, write them on the letter. So in the US, usually you only use the first component. Everything here is optional. But in the Netherlands, we specify everything. So actually this, what seems pretty simple, it's of a code FN. The same for name in context. You can have must, formatted name, much more information in there. And then for each table, I'll give you an example, points. It is defined in this table what are values that are allowed to be put into this field. And to give you an example here, you have different type of names. So a display name, that would be the name that people are familiar calling you. So think about an artist. You have a display name, that is what everybody knows you, and then you have your legal name. So how are you? What is your last name in your passport, basically? You can have nice stuff such as a nickname, which I'm looking for. Yeah, nickname. So hey, my name is Jonathan, but people both record Jonathan because that is what's on the passport, and John, so that when a nurse goes to the hospital, they will call him, hey, hi John, how are you doing? Not hello Jonathan. That is examples. So do not be scared with this. It looks very complex, but really it's because it is pretty well documented. The thing is, this is what a name would look like. So the entire specification, everything that we have here, starting from here to going down in this whole table, etc., this translates for this patient in basically 4 bits. And if you counted here, you would see that the number 3 in Roman letters, that would be 1, 2, 3, and 4 suffix. Actually, 3 as an example here: junior, senior, etc. Maybe going to the chat, I see Biswajit had a question. Is the position of the component in the line fixed? I'm not sure that I completely understand your question. So if you could unmute yourself and explain to me what the question is exactly. not sure if you're hearing me. Because I understand the position of the component. I guess, are the segments in sequence? Yes, okay. So basically, the lines that we had in our example, could you have, for example, MSH, then a PID, and then an EVN, and then a PV1, and then NK1? The short answer is no. If we go back to the specification of, for example, an AO1 message, here the order is specified. So you always have an MSH first. You could have multiple SFTs, which personally I've never seen. Also UAC, never seen. But then you've got an EVN. You need to have that before you have a PID. And then you can have a PV1. If you want, you can have other segments in between. For example, PD1, that is additional demographics. So PID segments has, let's say, about 40 different fields. It's not enough to send everything you want to send. So there is another one optional if you want to send funky stuff. Let's see what it is. For example, handicap, or your living will code, or if you're an organ donor, or if you are known duplicate, or what kind of military rank you have. That all those things, that is not necessarily something that all patients would have. So by default, you would not send such a segment. But if you need to send it, if you need to indicate this is a general, and maybe your hospital treats the patient differently, you never know, then that is information that you are able to send. So I think this answers your question, right?
May I ask another question?
Go ahead.
You said that you were making broadcast of those messages, but you said that there was also a system to make queries, and if I remember correctly, maybe I'm not, but
yeah, that is correct. So the idea. Oh, go ahead. Sorry.
Those queries are also specified by the HL7 specification, I suppose.
Yes. So to go to your question, the examples that we were looking at was an actually AO1 message. So that is a message that we called unsolicited, because the lab has not asked you, can you please admit the patient? It is basically just listening, and a patient is admitted in GNU Health. The event has happened. The message is created. It is sent. Sorry, it's sent out without the lab having to ask for it. That's unsolicited. Then you have solicited messages, such as a query. The lab would like to know where the patient is. So if I show you another screen now, where are we? So showing you my file manager. This is the content of the HL7 specs. So you see there are quite a number of different chapters. We were looking at the chapter number 3, patient administration. There's one chapter called queries. And just before I open this, to give you an idea, we've got introduction, which I'm not sure I've ever read. Bit of the data types. So I had shown you a quick example of what a name could look like. Other stuff here that is basically a bit of definition. Patient, and then we get into the more clinical side. Patient admin, your orders, your queries, the financial stuff that I explained. Observation, that is what a result on an order is. So master files, you can keep your list of physicians in sync, for example. I don't know what the medical record is, but scheduling, so appointments, you can send the appointments placed in GNU Health, you can send it to another message, or maybe the hospital has a different scheduling system and GNU Health can receive scheduling messages, so it knows, hey, this patient has an appointment. And other stuff that you see here, which I guess are a bit less used. Personal management, so you can keep in sync all your users and stuff like that. Materials management, that is a funny one that I did. I implemented that at my last hospital here. That is for surgery. You have a system that has a list of all the different surgical material that are available, and you can send the messages from, we are out of this specific material, or now we have this one, etc. So you can keep the system in sync, so that if a surgery is scheduled, you can say, give me all the default materials that we have determined we need for this surgery, and you can know that it's possible because the system told you, yes, we have those materials. Actually, I'm not going to open the queries. If you are interested, you can read it. It just looks like the rest of the documentation that I already showed you. Okay, Nicolas, you also mentioned the twisted HL7, which apparently implements MLLP. Oh, now that I remember, actually, the Python HL7 library that I mentioned does support MLLP. I remember. I am not familiar with twisted HL7, so I will have a look at it. It's probably another HL7. So let's see another question from Biswajit. Sorry if I'm mispronouncing your name. Broadly speaking, would it be right that once this is in place, a GNU Health user will be able to order lab tests from within? Yes and no. It kind of depends on what would be implemented, right? Again, my suggestion, I don't know if you were there in the beginning of the presentation or in the middle or the end, but my suggestion is that we start with a patient information. So the example message that I showed you, the AO1, the admission message, that would be what I guess it's best to start with. But if we start with, if we have this, we can then indeed include an outgoing order, incoming results interface, so that indeed a user could in GNU Health place orders, and those are then electronically sent out to a lab system. That is definitely possible, and all the hospitals that I work with have those interfaces in place. So yeah. I see that Sebastian has been looking a bit into the twisted HL7, and apparently there are complementary Python modules for handling HL7 data. So, I mean, the Python HL7 is the one that I'm familiar with because I've been doing a little bit of patching and I've submitted a code review, but I am absolutely not tied to it. So I will have a look at this twisted HL7 and have an idea of try to test it out. Greg asked a question that I think Sebastian will be able to answer as well. Does there exist a populated test database for GNU Health? I know there is a demo system that you can connect to so that you can go and test it out. It's actually also available if you download GNU Health. There is a script you can run which will populate a database with, I think there's one sample patient, etc. But there is something. I don't know in how much it is populated in, let's say, depending on what you want to do with it. But obviously you would be able, since it's free and open source software, you are able to download it and put patients that you want in there, and then you can test and say, yeah, I know I've put 4 patients, one of it which is the mother of another one, and then if you want to run queries and test how it works, you're able to do it. And Sebastian confirms there is an online demo database that you can connect to. Okay. In case you have more questions, go ahead, fire. I'm ready to answer. Otherwise, I want already to thank you guys for listening, for being an interesting audience and having nice questions. What I want to say, and that's probably more to Sebastian and Luis, who are really like the developers, the main developers, let's call it, of GNU Health. I would be very interested in helping you guys implement that. I am not familiar with Mercurial, your source control, but I'm sure we can figure it out. I know about SVN, Git, etc., so that should not be a problem. My biggest question is, how can we, and apparently Nikolai is a Triton core developer, so that's good to know. My biggest worry / starting point is, how would you handle those events? So assuming you admit a patient, how are we going to tell the HL7 module, please create a message? I guess we have to find a way of embedding kind of like hooks in the code that says, I assume you have a code that says this is the place where I now file to my database that the patient is admitted, we would need to add a line that says, please let the module, if it's installed and configured, know that you should send a message out. And that is the part where I'm not, since I don't know the code very well, I'm not feeling comfortable to start. But I guess if you guys can start to think about that, and I could help more on the technical side, how do you like generate the messages, test them, etc. I'm pretty sure we can find a way to.
Yes, I don't know, Nicolas. Maybe using triggers.
He's using what?
Triggers.
Triggers. Yeah, maybe. I must say we haven't thought yet about how we will generate this pool of events and how we will handle them. So we are kind in the blur now.
Mm-hmm.
So it needs to be a bit. We need to sleep on it and think about but maybe triggers to create other records somewhere, or post message to maybe another system that will create afterwards HL7 message.
Yeah, what you mentioned about an external system, I would encourage you guys, if you do that, to really include the HL7 module as really a Triton module, so as part of GNU Health. The benefit is that you are as close as possible to the database, and if you need some context, for example, hey, an order was placed, well, you can look at the database, who was the patient, and then you retrieve this information, because on an order message, you will send the same PIT segment you would send on an ADT message. So if I would say, don't make this an external system where you post information and then that system generates, because you are farther from the database.
Yeah, probably right. It was just an idea.
Yeah.
So no, we don't have yet a solution. So, but
that's not a problem. I think it's just, if you guys can think about it, how would you? So an event happens. How can you let another module that it happened and it needs to do something? That is the first step to have an idea of how to develop that. Okay.
Mm-hmm.
So I think we can close it here. I will on the Google Plus community for HL7. I will put a link to the slides that I've shown, so that there were a few links that I had embedded in there. I will actually update it to put a link to the twisted HL7 module. So I'll do that in a few minutes. As I mentioned, this has been recorded, so it will be visible on YouTube. So I don't know if the post is automatically added, but I will make sure that the link appears on our community page. And yeah, just wanted to thank you for your attention, and I hope you've learned new stuff. HL7 seems complex, but as I mentioned, it's just text-based. There are pipes that limits it, and you just need to know, oh, patient name, yes, that's PIT 5, and that's something that you learn over time.
Yeah. Thank you. Thank you very much.
Thank you, Emilian, for your time.
Yep. Have fun, and we'll be keeping in touch. Ok. Allez, bonne soirée à tout le monde.